The Australia TradeCoast stretches across 1,047 hectares. It's the country's fastest-growing container port, managing a relentless daily flow of critical imports and exports. This single logistical hub supports over 70 businesses and 60,000 employees, working continuously among the heavy gantry cranes and container stacks. But operating at this scale comes with a specific geographic vulnerability. The entire infrastructure sits directly adjacent to the open waters of Moreton Bay. That adjacency introduces a constant, invisible threat. The wind carries highly concentrated ocean salt spray, coating every exposed structural surface in the facility. Ocean spray is packed with sodium chloride. As the moisture evaporates in the subtropical heat, microscopic chloride ions are left behind, bonding tightly to the metal and concrete infrastructure. This animation shows exactly how that breakdown happens. The chloride ions easily penetrate standard protective paint coatings. Once they reach the metal substrate below, they combine with Brisbane's high humidity to trigger an electrochemical reaction, rapidly oxidizing the steel from the inside out. A structure sitting half a kilometer from the coast experiences chloride deposition rates 3 to 5 times higher than facilities located 2 kilometers inland. Within this specific coastal zone, accumulated dirt and salt residue are active chemical catalysts, rapidly degrading the structural integrity of the steel. Standard janitorial sweeps cannot stop this chemical process. Keeping this infrastructure standing requires a highly engineered preventative maintenance strategy designed specifically for aggressive marine environments. A massive port facility does not corrode at a uniform rate. Engineers classify this varying environmental threat using the ISO 9223 standard, mapping exact levels of corrosivity across the site based on proximity to the water. On this top-down breakdown, the water-adjacent edge is the splash zone, categorized as C5. Taking direct saltwater hits and wet-dry cycles, defending it requires heavy-duty epoxy coatings and deep pressure cleaning every 30 days to strip away salt before it breaches the paint. Set slightly further back is the tidal zone. While it avoids direct waves, intermittent spray gets trapped in the joints and crevices of the steelwork, requiring a scheduled bi-monthly cleaning protocol. Even the inland atmospheric zone remains at risk. Wind-carried salt still reaches these structures, making a quarterly cleaning cycle necessary to prevent long-term degradation. Fresh paint alone fails if the surface beneath is contaminated. A steel beam cleaned quarterly and recoated annually will consistently outlast one that is painted once and left unwashed. Mapping these specific exposure zones and adhering to their precise maintenance schedules is the only proven method to stop multi-million-dollar maritime assets from rusting away. This corrosive threat doesn't stop at the exterior walls. It easily penetrates the massive 12-meter high bay warehouses located inland. Inside, heavy forklift traffic kicks up fine industrial dust. When this dust mixes with the airborne marine salt, it forms a highly corrosive slurry that settles onto the structural metal storage racks. Clearing this indoor hazard requires industrial HVAC filtration systems, scheduled overhead scrubbing, and maintaining safe air quality. Back at ground level, the loading docks face a completely different set of mechanical and chemical pressures. These concrete heartstands take relentless physical abuse from heavy cargo machinery. At the same time, constant diesel and oil spills rapidly break down concrete seals and strip away crucial non-slip safety coatings. Extracting embedded contamination requires aggressive remediation. Maintenance crews deploy specialized degreasers and 4,000 psi hot pressure washing to strip oils without fracturing the concrete. Maintaining strict operational safety and avoiding facility shutdowns means actively neutralizing both the chemical threats in the air and the physical industrial abuse on the ground. All of this heavy maintenance creates a sharp operational paradox. Facility managers have to aggressively wash away highly toxic oils and concentrated salts while operating directly on the edge of a delicate marine ecosystem. The Queensland Environmental Protection Act of 1994 draws a strict legal boundary around this process. Discharging trade waste like sediment, ultra pH water, or oil runoff into Moreton Bay triggers severe regulatory penalties and potential shutdowns. To comply, every washdown requires extensive pre-cleaning engineering. Teams must deploy temporary bunding, silt fences, and sediment filtration systems to capture and treat every drop of oily discharge before a single pressure washer is even turned on. Proper industrial maintenance requires protecting the physical asset from the environment while simultaneously protecting the environment from the toxic byproducts of that maintenance. For port operators, balancing these engineering and environmental demands comes down to a specific financial framework: life cycle asset maintenance planning. The financial math is stark. A cycle of preventative maintenance costs roughly 15 to 20% of what a reactive, catastrophic structural repair would demand. When a corroded bolt shears off under pressure, the replacement cost is negligible compared to halting operations entirely for an emergency repair. By combining preventative cycles with the avoidance of emergency downtime, port facilities typically reduce total ownership costs by 70%.